Hello, good morning. Take a look at this advanced problem 2025. Here they are saying, and of course, this problem was from matrices. It's a very simple question. So let I is equal to 1001. Of course, it is a identity matrix. And P is equal to 2003. A complete matrix was given. And Q, some elements are hidden like X, Y, Z, and 4 was given. For some non-zero real numbers, X, Y, Z, for which there is a 2 by 2 matrix R such that with all entries being non-zero real numbers, and he said 2 by 2. So this is important, 2 by 2 matrix. So we'll write first what were given. So identity matrix I 1 0 and 0 1, and P is equal to 2 0 0 3, and Q is equal to X Y Z 4. And here X Y Z are non-zeros, non-zero values. R, they said, for the matrix capital R, they said it is a 2 by 2 matrix. So you can take R1 comma R2, where R1 is equal to first column, R2 is equal to second column. For this kind of problems, we will take like this. And we are using eigenvalues because they said QR is equal to RP. So what is the value of Q, X, Y? We will solve in general ways. So Q R1, R2 is equal to R1, R2. P is 2003. If you do multiplication with this R1 and R2, you can see 2R1 plus 0R2. The complete column was multiplied. And next 0R1 plus 3R2. Of course, its value will be 2R1, 3R2. So therefore, Q of columns R1, R2 will be equal to 2R1 and 3R2. This means the first column R1 is eigenvector of Q with eigenvalue. Also, second column R2 is an eigenvalue of Q, eigenvector of Q, eigenvalue 3. So 2 comma 3 you can use to determine. For a trace is equal to sum of eigenvalues, and determinant is equal to product of eigenvalues. So remember these two values as formulas. Q is actually for problem was completely depend upon the values of. So look at the determinant they are saying, and also determinant, right? Q minus 2a, they are talking about only the matrix Q. So trace of Q, look at the matrix Q, how they mentioned Q. Q was X, Y, Z 4. Now trace means sum of eigenvalues 2 plus 3. Trace means X plus 4 is equal to 5. X is equal to 1. Det of Q is equal to product of eigenvalues 2 into 3. That means 4x minus yz det of Q, which is 6. 4 into x value already we got 1, and yz is equal to minus 2. Therefore, x is 1 and yz is equal to minus 2. Let's calculate Q minus, check the problem. First option, Q minus 2i is 0, determinant of. Det of Q minus 2i is 0, they mentioned. So what is Q minus 2i? So you can see Q minus 2i matrix is x minus 2, y minus 0, because I is 1, 0, 0, 1. Okay, I will write details. Q matrix xy at 4 minus 2i is 2, 0, 0, 2. Det of, they are saying 0. So this is x minus 2, det of y and z, and 4 minus 2, 2. Is it 0? Substitute x value 1. So minus 1 y at 2. So minus 2 minus yz is equal to 0 means yz is equal to minus 2. Yes, it is true. Let's verify option B. Option B, it says det of Q minus 6i is 12. We already calculated. We will again calculate xy Q minus 6i at 4 minus 6006 under determinant is equal to 12. So x minus 6 at y minus 2 equal to 12. Minus 2x plus 12 minus yz equal to 12. X is 1, so minus 2 plus 12 minus yz is equal to 12. 10 minus yz is equal to 12. Of course, again, we are getting yz is equal to minus 2, which is also true. Determinant of q minus 3i is 15. Determinant of q minus 3i, they are saying it is 15. Q is xy z4 minus 3i 3003. And the determinant is equal to 15. X minus 3, y 4 minus 3 is 1 is equal to 15. X minus 3 minus yz is equal to 15. Minus 2 minus yz is equal to 15. And yz is equal to minus 17. So this is incorrect. Actually, yz is minus 2. Fourth option, yz is equal to 2 is clearly incorrect because yz is minus 2. So by observing all above options, A and B are correct.